still working on extra practice solving exponential functions, and we need to isolate the variable as much as possible. So we're going to subtract 10 for both sides. We get 6 to the 3x minus 8 equals 35. And now we have it in a format where we can actually solve this. And once again, use log to solve it, use natural log to solve it, whichever works for you. But I'm going to use log. And when we do, we've got log of 6 to the 3x minus 8. And we have log of 35. And that means that we're going to have to take this 3x minus 8, and we have to write that out in front of our function. And now what we have, 3x minus 8, and it's going to be that whole value needs to be multiplied by log of 6. And then over here on the right side, we have log 35. We need to distribute log of 6 is going to be distributed over the 3x and the 8. So now what we have is we have 3x log of 6 minus 8 log of 6 equals log of 35. And what we're trying to do is we're trying to solve for x. So we want to get the x term by itself. And we're going to add 8 log 6 to both sides. So we end up with 3x log of 6 equals log of 35 plus 8 log of 6. And what we're trying to do is we're trying to get x by itself, and it's 3 times x times log of 6. So since those are all multiplied together, we're going to divide by 3 log of 6. If we divide the left side by 3 log of 6, we need to divide the right side by 3 log of 6. Just notice over here that the 3's cancel out, that the log of 6's cancel out, and that means that we're just left with the x over here, which is what we want. And then this log of 35 plus 8 log of 6 divided by 3 log of 6 is our exact answer. And I'm going to use my fraction button, but again, if you don't have a fraction button, you need to be really careful with your parentheses. But alpha y equal, to get your fraction button, and log of 35, close the parentheses, plus 8 log of 6, close the parentheses, divided by 3 log of 6. Just checking my work here, yes. And when we press enter, we get that value. So we're looking here to find the approximate. And when we find the approximate, we're rounding. So on this particular problem, we are looking at the 9 to determine whether to round at 0. And because 9 is greater than 5, we're going to get x equals 3.3281. when we round to the nearest 10,000. Problem number 5 is, as you flip the paper over, again, the idea is that we need to have the variable isolated as much as possible. And it says 3 times 17 to the 2x. Well, we need to divide by 3. When we divide by 3, we get 17 to the 2x equals 21. And that's helpful here, because now we have our equation in a format where we can solve with a logarithm. Again, if you have Mrs. Krause, she would put in ln right there. 17 to the 2x equals log of 21. And again, it should sound like a broken record if you've really been doing this practice, or if you've been watching all these videos, and hopefully if you're watching the videos, you're also working them out. You need to make that 2x a coefficient. So this is going to be 2x log of 17 equals log of 21. And we're almost done with finding the exact answer, because it's 2 times x times log of 17. Since those are all multiplied together, we can divide by 2 log of 17. And when we do, the 2's cancel out, the log of 17's cancel out, and we will have our exact answer of x equals log of 21 divided by 2 log of 17. That's our exact answer. But let's see what our approximate answer is. And without using the fraction button on this one, and let's put parentheses, log of 21. Close that parentheses on that 21, and in fact, close it a second time. That's the top of it. Top of the fraction divided by parentheses 2 log of 17. Close the parentheses and then close it again for the denominator. And there we have our decimal approximation here, and we've got to determine how much we want to round, where directions tell us to round to the nearest 10,000. But as I take a look here, we're looking at 9, and 9 is going to determine what we do to that 2. So for our approximate, we're going to get 0.5373, because the 9 after the 2, the 9 is higher than 5. And that causes us to round up. And our last problem here. 6 to the 7x equals 11 to the x minus 4. Already isolated, so we're ready to put in a log. Log of 6 to 7x equals log of 11 to the x minus 4. One less time. Make that 7x a coefficient. Make this x minus 4 a coefficient. So we have 7x log of 6 equals x minus 4 times log of 11. Be careful here, because the x minus 4 in its entirety needs to be multiplied by log of 11. In other words, what we're going to have to do is we're going to have to distribute the log of 11. So we have 7x log of 6 equals x times log of 11 minus 4 log of 11. What we see in this problem is we see that we've got 2 terms that have x's in them, so we need to put the x's on the same side of the equal sign. So let's subtract x log 11 for both sides. Now we have 7x log of 6 minus x log of 11 equals negative 4 log 11 over here on the right side of the equals. And we've seen it before, even on this paper. Since we have more than one x term, we need to factor out an x. And when we factor out an x, we're left with 7 log 6 minus log 11 equals negative 4 log 11. It's x times this value, so we're going to divide by 7 log 6. 7 log 6 minus log 11. And over here, we're going to divide by 7 log 6 minus log 11. And that turns out to be our exact answer of negative 4 log 11 divided by 7 log of 6 minus log of 11. That is our exact answer. And then what we want to figure out is what's our approximate answer. So we're going to pull out our calculator. And I'm going to use my fraction button, alpha y equals, to type this in. Negative 4 log 11 divided by 7 log 6. Check here, yep, minus log 11. Close that parentheses. And when we type that in, we get that decimal approximation. And let's look at our rounding to finish. Well, 0.94550 is going to determine what we do with that 5. It's actually negative, so we're going to end up with x equals negative 0.9455 for our approximation.